Hi, I'm Abdul Manan Beg. I'm from the Department of Biological and Biomedical Sciences and represent a group, Emerging Infectious Diseases Outbreak. This paper was published in October 2020, before which in March 2020 we highlighted that loss of smell and taste could prove to be significant symptoms in COVID-19. That paper can be seen at the bottom, and in this publication we actually detailed those routes by which the SARS-CoV-2 can reach the brain. Seen here in the left-hand panel diagram is the oropharyngeal mucosa being seeded by SARS-CoV-2, through which a retrograde neuronal transport route could make the virus reach the brain and the brainstem in particular. Through the nasal cavity, you can see as the route A3 is showing you, and till the end of the arrow A1, the SARS-CoV-2 can cross the cribriform plate of the ethmoid bone close to the olfactory mucosa and reach the olfactory bulb, which now has been demonstrated in several published papers. At this time, when we speculated this, there were no traces of SARS-CoV-2 reported in any published papers, but subsequent papers proved the presence of the virus in olfactory bulb, olfactory mucosa, and now in a latest paper in the brainstem as well. Regarding the cribriform plate of the ethmoid bone and the transcribrial route that it could take, now papers have validated the presence of this virus in the olfactory bulb and the fact that cribriform plate is a very convenient route for this virus to reach the olfactory mucosa. Since olfactory nerve bundles passing through the cribriform plate are ensheathed by arachnoid and pia mater, the possibility that it could take a route via joining the CSF flow is highly possible and was reported in this paper. As I told you before, that this paper was published in October 2020. Papers now emerging in November and December 2020 have validated the presence and the virtual presence of the SARS-CoV-2 within the olfactory bulb and the olfactory mucosa. Also, the brainstem excess of this virus and its presence in the medullary reticular formation has recently been published in Nature Neuroscience on December 8th, 2020. In a live presentation, possibly you may ask me that what is the evidence, clinical evidence, that this virus possibly reaches the brain stem. Before October 2020, we noticed that patients with SARS-CoV-2 infection known as COVID-19 were having problems with the spontaneous breathing. And as you know, that these vital centers that regulate the respiratory control by autonomous phenomena are located within the reticular formation of the brain stem. They are known as inspiratory area. So shown here is that possibly a retrograde neuronal transport or its access through the CSF, it could go affect the respiratory centers, resulting in those clinical patterns that were observed in patients with COVID-19. Majority, if not all of the hints given in this paper now are being proved by subsequent papers being published in top science journals that what we speculated was correct, and by demonstrating the viruses in the area that we show here in the diagram, it's now certain that the virus is affecting the central nervous system. Thank you very much. Have a nice day.